Today we're going to continue with discrete random variables, and we're actually going to wrap up this topic by looking at how we can employ all the skills we've picked up so far through this chapter along with our GCSE problem solving skills together, some nice multi-step problems. You should expect to have some simultaneous equations to solve, to work with inequalities, and to use all the skills we've seen so far in this chapter: calculating the expectation of x, calculating the expectation of x squared, calculating the variance of x, and being able to use a linear function to transform from one random variable, maybe an x, to another random variable, which may be y. So let's see if we can use one problem to illustrate all of those problem solving skills in action. In this question, we've been told that the discrete random variable x has a probability distribution as shown. So we have a sample space of possible outcomes from -2 through to +2. Probabilities are given, and there are 3 unknown probabilities, a, b, and c. Next, we're given the linear function y equals 3x minus 1. And then finally, we're given an expression for the expectation of y and for the variance of y. The first thing we're asked to do is to find the expectation of x and the expectation of x squared. Well, since I know the expectation of y and I know the linear function, I should be able to do some rearranging to make expectation of x the subject and solve. So let's just start with that written down. The linear function y equals 3x minus 1. The expectation of the left hand side equals the expectation of the right hand side. We can rewrite the right hand side and we can substitute the value expectation of y. Now we're just going to do some rearranging, trying to make the expectation of x the subject. So add 1 to both sides, divide both sides by 3, and let's just write expectation on the left. The expectation of x, negative 0.05. I also need to find the expectation of x squared, but I don't have enough information to do that right now. But if I use a similar process for the linear function with the variance, I should then have the variance of x and the expectation of x, and with those two, I can find the expectation of x squared. So here we go. The variance of the left-hand side is going to equal the variance of the right-hand side. We know that adding and subtracting doesn't change the variance. It doesn't have any impact. So I'm just going to rewrite this straight away as the variance of 3x. The 3 is going to come outside and become the coefficient after it's been squared. So we have 9 variance of x. And we can substitute in our value for the variance of y, 13.95. Some more rearranging, and we get the variance of x is 1.55. Okay, I have the variance of x and the expectation of x. Now these are linked by the formula for the variance. We know variance of x is the expectation of x squared minus the expectation of x. Let's substitute and find the expectation of x squared. So 1.55 equals the expectation of x squared minus 0.5 squared, or minus the negative 0.5 squared. Okay, rearranging from here, we get the expectation of x squared is 1.8. So using that linear function and the formula for variance of x, we've actually managed to find the expectation of x, the variance of x, and the expectation of x squared. 2 of these the question actually asked for. In part B, we're asked to find the values a, b, and c. And we should know already, to find 3 unknowns, we're going to need 3 different equations. The first one, maybe the simplest of all of them to use, is the fact that the sum of the probabilities is going to be 1. So this row of probabilities, 0.3 plus a plus 0.25 plus b plus c is going to equal 1. So that's the first equation. Let's simplify and rearrange that just to make it more usable, and we get a plus b plus c equals 0.45. I can get another equation from the expectation of x. So each of the x values multiplied by the corresponding probability, and then we'll sum all of those product pairs together. So we get -2 multiplied by 0.3, -1 multiplied by A, 1 multiplied by B, and 2 multiplied by C. And all of that we know already should equal -0.5. Once again, let's rearrange and simplify, and we get -A plus B plus 2C equals 0.1. That's two of the equations to help us solve. The third equation we can get from the expectation of x squared. So each of the x values are going to be squared and then multiplied by the probability. So -2 squared gets us to 4, -1 squared gets us 1, 1 squared gets us b, and 2 squared gets us 4. Once again, we're going to expand, simplify, and the equation that we get, a plus b plus 4c equals 0.6. Okay, three equations, three unknowns. We have two ways to solve. If you know how to solve using a matrix, I recommend you go ahead and do that. If not, we're going to solve by rearranging and substituting. Out of all of these, the one that I'm going to rearrange for the substitution is the second one. It already has a -a, and I feel like I make that the subject, and then I'm working with lots of positive values. So, a equals b plus 2c minus 0.1. I'm going to substitute that into equation 1. (2b plus 3c equals 0.55. If I substitute into equation number 3, b plus 2c minus 0.1 plus b plus 4c is all going to equal 0.6. Once again, rearranging there, and we get 2b plus 6c equals 0.7. Here's the simultaneous equations that should look familiar. It's GCSE territory now. From here, we should be able to solve for c and b. Whichever technique you're using, whether it's elimination or substitution or using your calculator's equation solver, we'll get answers for c and b of 0.05 and 0.2. To find a, we're going to substitute these values back into that rearranged equation we had earlier. So a equals 0.2 plus 2 times 0.05 minus 0.1. A equals 0.2. So here's my three unknowns, just as the question's asked for. We can go back to the original probability distribution and we can actually substitute numerical values for these unknowns. So if I just add a third row here, all numerical values, that will help with any questions coming up asking about probabilities. And that's exactly what we have in part C. Part C wants us to find the probability that x is greater than y. I don't want to mix up x's and y's. These are two different distributions. I'm going to use the linear function, substitute it into this inequality so that I have an expression just in terms of x. So, since we know that y is 3x minus 1, x is greater than 3x minus 1 is equivalent. Going to rearrange this. I'll take the x's to the right hand side, numbers to the left, and simplify to get the probability that half is greater than x. And if you want to write it a little bit more familiar or in a familiar form, this is the probability that x is less than a half. So from the probability x is greater than y, we've rearranged all the way to the probability x is less than a half. Now we look at the table. Which outcomes are less than a half? What are the probabilities associated with those particular outcomes? If we sum them together, that will be the probability that x has a result which is less than half. These are the values we're looking for, and when we sum them together, we get 0.75. The probability that x is greater than y is 0.75. So in this question, there was actually quite a few skills that we needed to put in place to solve the problem. And they were a culmination of all the skills we've been using so far in this chapter, so far in this topic. So, can you have a similar strategic approach and solve problems grounded in probability distributions, grounded in discrete random variables?